Welcome everyone and thank you for joining today's session. We're excited to show you how to accelerate development on Nuvoton's M55 series microcontrollers using Keil Studio and NuCodeGen. My name is Christopher Seidel from ARM and I'm presenting together with Chris from Nuvoton. Today, we'll walk you through how Keil Studio and AI-powered workflows can dramatically streamline your development experience from setup all the way to running code on your board. Here's what we'll cover today. I'll begin with a quick look at the Keil MDK Nuvoton edition, including what developers can access for free and how they can get started. I will also show you how you can use the Nuvoton BSP from GitHub in Keil Studio. After that, Chris from Nuvoton will give us an overview of the M55 series of devices, what's new, why they matter, and how they support modern AI-ready workloads. The core part of the presentation will be a demo. We'll create a new Nuvoton project, configure the device with the help of NuCodeGen, build it, flash it to the board, and verify everything is working. We'll wrap up with key takeaways and a short Q&A session. Here's an overview of our special offering for Nuvoton customers. The Keil MDK Nuvoton edition provides a commercial use environment with no code size limitations. It supports all Cortex-M devices from Nuvoton, so developers can use it across the full device range without restrictions. This makes it extremely easy to evaluate or start new projects on any Nuvoton Cortex-M MCU. It consists of our well-known tools, including Microvision for those who need to support legacy projects. Our focus today is Keil Studio, our new VS Code-based IDE. The ARM compiler for embedded offers superior code size and performance, especially on targets like the Nuvoton M55 M1 with its Helium instruction set. Devices and boards are supported via SEMSys packs. Our field-proven professional middleware is open to all Nuvoton customers and is available as source code. Via SEMSys DApp, you can use the onboard NuLink adapters to debug your application. Let me show you how to get it. You go to this website, and don't worry about the link, you'll get access to the slides after the webinar, including the link. You enter your contact details, and you'll be sent the application note that explains how to activate the edition in Keil Studio and Microvision. Today, we'll be using the NuMaker M55 M1 development board that is shown here, and Nuvoton has published a board support pack or BSP for this development board on GitHub. And I will show you now quickly how you can use that in Keil Studio. First of all, of course, you need to install Keil Studio from the VS Code Marketplace. You will find the link here. Then you download the zip of this BSP repository from GitHub. And then you open the BSP folder in Keil Studio, so in the Visual Studio Code, switch to the SEMSys view, and select Open Solution in Workspace, which I will show you now. Here's Keil Studio, and I now have the folder of the zip file already opened in Keil Studio, and I click on Open Solution in Workspace. And you see Nuvoton have done a tremendous job to add lots of sample code, examples how to use different interfaces and whatsoever with this development board. So it's a very long list of solutions that you can select from. I will now use the Blinky, and to show something different, I will go for the FreeRTOS one. And first, let us check what we can maybe change here. So this is the Manage Solution dialog. You see you can choose to use either ARM Clangs or ARM compiler 624 or the GNU compiler. We can select between build types. Well, here's obviously just a release type in there. But what we definitely need to do is enable the debug adapter. So enable this one. And I know that this development port has a NuLink on board. So this is now set, and I save it. I have already built the project in the background before, and I will now directly go into the debug session. It's flashed onto the target, and we end up at main. I run the application for a little while. You see, for example, down here, we record the runtime. I stop it, and we can, for example, using the XRTOS view, examine the threads that are running in this application. It's quite a bunch of threads, and we can examine that in this XRTOS view, for example. Of course, we have the usual call stack as well. We can check our registers. So everything that you would expect from a debugger is all available in Keil Studio as well. Before I hand over to Chris, who will tell us more about the Nuvoton M55 M1, here's a quick look at ARM's EthosU NPUs. These accelerators bring efficient neural network performance to very constrained embedded devices. Instead of running all ML workloads on the Cortex-M core, the EthosU handles the heavy compute, so the CPU can focus on the application. The result is a huge boost in inference speed while keeping power and memory requirements low. And the best part is that integration is straightforward. You can keep using your Samsys DSP and Samsys NN software stacks. Together, Cortex-M plus EthosU give you scalable architecture for running real AI workloads at the edge. So that's great compute technology that ARM offers, but how does software benefit from that? The Embassy Audio Mark benchmark gives you an indication. It implements a wake-word spotting algorithm that you find, for example, in smart speakers, and contains a complete audio front-end with echo and noise cancellation. It uses Samsys DSP and Samsys NN software libraries. A Samsys solution software layer simplifies the adoption to different hardware. We ported this benchmark to various ARM processors, and the diagram shows the performance. It even works on a Cortex-M4, which is our baseline. You can see the performance gain across the different processors. With Cortex M55 using Helium, it runs 6 times faster, and when you add an EthosU 55 NPU, the gain factor is 22. Now note that the ML word is actually 100 times faster, but the benchmark shows a complete application and not just the ML part. Chris, can you give us a quick tour of the Nuvoton M55 device series?
Hello everyone, I'm Xin-Zhi Xie. You can call me Chris, the department manager at Nuvoton responsible for AI product. Today, I would like to share with you some of the upcoming product and ideas that Nuvoton will be launched in the AI field. Microcontrollers are well suited at handling sensor data such as image, microphone signals, voltage, and current. By running AI modules directly on a microcontroller, diverse applications become possible, including image recognition, object detection, voice print identification, and noise reduction. This highlights the key advantage of endpoint AI. It reduces both the cost and scale of AI deployment, while operating independently of network connectivity. The key challenge lies in compressing the model and efficiently deploying them onto resource-constrained microcontroller. Nuvoton provides dedicated tools to simplify this process and make AI on microcontroller more accessible. The AI deployment flow generally consists of the following steps: preparing raw data and training the model. And second, training and validating the model using NuML Studio in the cloud or NuML Wise on the local PC. And finally, using the NuML toolkit, the module is compiled with the beta compiler and deployed directly onto the M55 M1 AI microcontroller. Traditionally, this process is quite complex, requiring multiple runtimes and extensive library support. To address this challenge, Nuvoton provides a comprehensive set of toolsets that support various AI scenarios, significantly simplify the transition from model deployment to hardware deployment. Okay, let's look at a real-world application, a voice-based device control. The requirement is simple but powerful. The first is users speak naturally. device responsible immediately. And last one, no internal connection is required. Instead of fixed keyword, the system using natural language understanding or NLU. For example, users don't need to memorize command like AC on. They can just say, switch the just run air conditioner to heating mode and raise the temperature to 26 degrees. This single sentence includes intent, location, mode, and value. The voice system supports wake-up word detection, speech recognition, fourth sentence understanding, optional speaker or voice print verification. All of this run on device using a lightweight NLU model. Once the command is understood, the microcontroller immediately executes the corresponding device control action. This is a perfect example for endpoint AI in action. The M55 M1 architecture is very similar to that of the traditional microcontroller. Developers do not need to worry about difference between the microcontroller they are currently using and the M55 M1. Featuring a M55 M1 featuring a Cortex-M core with embedded 2 MB flash and 1.5 MB SRAM. The M55 M1 can be used just like a conventional microcontroller. It supports standard development workflow and can be programmed and debugged using Keil or IAR. The M55 M1 also offers rich peripheral support such including UART, SPI, I3C, and CAN-FD, high-speed USB, and Ethernet, and so on. Like traditional microcontroller, M55 M1 can operate at around 1 microamp in power down mode, with an independent low-power domain and RTC support. Ideal for always-on AI application. And also, security is built in at a hardware level, featuring Trust Zone, hardware crypto engine, and true random number generator. Secure key storage. This ensures that both firmware and AI module are protected. The key difference in the integrate is the integrated MPU, delivering 110 GOPS of computing power, more than 100 times higher than conventional microcontroller, making it compatible of supporting a wide range of AI module and applications. Okay, in a summary, endpoint AI represents a major shift in how intelligence is deployed. With the M55 M1 AI microcontroller, developers can now run a real AI inference on microcontroller and enabling offline, real-time, and private intelligence and achieve ultra-low power operation and scale AI to a cost-sensitive and battery-powered device. Next, we will talk about AI-enhanced development with NuCodeGen in Keil Studio. I would like to introduce NuCodeGen, an AI-assisted development tool designed for Nuvoton microcontroller development. NuCodeGen helps developers move beyond manual configuration by using natural language to generate code and manage the entire development workflow more efficiently. This slide highlights the core capabilities of NuCodeGen. NuCodeGen is a chat extension for Visual Studio Code built on GitHub Copilot Chat. Developers can use natural language prompts to generate code snippets based on Nuvoton's standard driver API or query information related to the Nuvoton's BSP. In addition, NuCodeGen integrated Keil Studio capabilities, allowing the AI to execute build, load, and debug commands directly from the chat interface. This enables an end-to-end workflow from configuration to deployment, with fewer tool switch and much faster build and debug cycles. NuCodeGen also supports custom command and a wide range of peripherals, helping developers build projects and identify the issue more efficiently. Instead of manually writing code, developers can simply describe layer requirements such as a clock setting, pin configuration, or peripheral behaviors. NuCodeGen then automatically generates the corresponding code, saving both time and effort. NuCodeGen also allows developers to directly ask questions about IP and APIs. The elimination of need to consistently search through technical reference manual or documentation files, making development faster and more convenient. By integrating build, load, and debug into a same interface, NuCodeGen significantly reduces tool switch and speed up testing and debugging. As a result, developers can focus more on application logic and less on development overhead. So far, we have talked about what NuCodeGen can do. Now, instead of more slides, let me show you how it actually works in a real example.
Users enter prompts in the GitHub Copilot chat window. NuCodeGen then generates the required information and code. For example, we ask about clock settings. NuCodeGen lists all clock sources and system clock configurations. At the end, a sample prompt is also provided. Next, we want to build an SPI and UART communication example. We first ask about the clock sources for SPI, UART, and APLL0. Then we copy and modify the sample prompt. We request an SPI and UART clock setting example. In this prompt, we change the APLL0 clock source to HIRC with a frequency of 220 MHz. Configure UART to use APLL0 as its clock source, and set SPI to use PCLK0 as its clock source. As shown on the screen, NuCodeGen immediately generates the required clock setting code in main.c on the left-hand side. NuCodeGen also automatically compiles the project and confirms that the generated code builds successfully. After completing the clock configuration, we proceed to ask about pin settings. We ask which multifunction pins SPI0 supports. We confirm which multifunction pins are available for SPI0, copy the relevant sample prompt, and modify it to include the required SPI0 and UART pin assignments. After submitting the prompt, NuCodeGen automatically inserts the pin setting code into the existing clock setting program and configures the SPI0 multifunction pins accordingly. SPI0 multifunction pins are now configured. Next, we configure SPI settings. If there are any questions about the displayed information, we can use not only NuCodeGen, but also the nutrm command for further clarification. For example, we can ask about M55 M1 specifications, such as the differences between SPI mode 0 through mode 3. The nutrm chatbot searches the technical reference manual and provides the corresponding explanation. Similarly, we can ask what the SPI automatic slave select function is used for and new TRM will return a clear description. After understanding SPI features, we modify the sample prompt. SPI 0 is set to master mode 0. Each transfer uses 32-bit data length. Automatic slave select is enabled. An SPI interrupt is triggered after transfer completion. The goal is to transmit and receive 128 data items. After submitting the prompt, NuCodeGen automatically inserts SPI functions in the code. As shown on the screen, an error appears after compilation because the project does not initially include SPI.c, so the compiler cannot resolve the SPI-related functions. NuCodeGen automatically adds SPI.c to the project. The project is recompiled successfully. Next, we configure UART output. UART is used to verify SPI transfer results. We again modify the sample prompt to configure UART 0 as the output interface, which is used to print the results of comparing the source and destination data arrays. After submitting the prompt, NuCodeGen automatically inserts UART functions in the code. After the code generation is completed, NuCodeGen performs compilation once more to verify that the build is successful. Finally, we use NuCodeGen to download and debug the program by entering the debug code command. NuCodeGen downloads the compiled program to the M55M1 device and enters debug mode. After selecting the UART port and baud rate, the UART output is displayed directly in the console window. The message shows SPI transfer successful. At this point, we have successfully used NuCodeGen to automatically complete an SPI data transfer application from configuration to verification. Thank you.
Thanks, Chris, for this impressive demo. Before we wrap up, I want to highlight our set of on-demand webinars available for you to dive deeper into embedded development with Keil Studio and related ARM technologies. These sessions cover a range of topics, including general software development workflows, device configuration, and synthesis-based development using Keil Studio. We also offer webinars that explore more advanced topics such as dual-core debugging and AI integration using Keil Studio. Another session walks through accelerating machine learning model training and DSP development using the SDS framework. We also provide guidance on integrating and debugging functional safety features. All of these webinars are available to watch on demand, so you can explore them whenever it fits your schedule. To help you continue your development journey, we gathered several useful resources for you. First, the Keil Studio User's Guide provides a comprehensive overview of the environment and walks you through all the key features and the workflow. You can also explore a wide range of ARM-maintained examples on GitHub, which demonstrate best practices for SEMSys, RTOS-based development, and AI-related workloads. On the Nuvoton side, there are GitHub repositories and the NuCodeGen tool, both of which offer practical examples and automated code generation capabilities for Nuvoton MCUs. And finally, if you ever need assistance, Keil MDK support is available to help you troubleshoot your issues or guide you through more complex configurations. Thanks for joining us today. We're now happy to take your questions.